I told you I was going to have to do this myself. There's a 555 timer, basic astable oscillator. There's the 9-volt battery that's powering the 555 timer. There's, let's see, I have just the positive side connected to the TarBaby at the place where the positive function generator normally goes. The negative side isn't connected except by the ground loop through the instruments. And here we go. The top trace is this probe here, which is monitoring the output of the 555 timer directly. And the bottom trace is the MOSFET common drain trace, like I always show. And it's at 20 volts per division, sitting up at battery voltage plus, oscillations. The 555 timer is doing its thing. There's the zero marker, so it's making a negative going pulse right in there, and the phase relationship here is probably off because I can't use the internal trigger, or rather the external trigger of the oscilloscope. So there may not be the correct phase relationship being shown between where the oscillations are and the two traces. In fact, it's possible. Let's see what happens here if I do this. No. Okay. So at any rate, can you hear that? That's the oscillations coming over my computer speaker, and I can prove that to you by moving my hand around to change the. See there? Now I take my hand away from the wiring. Okay, so don't be worried about the phase relationship, but just, you know, there we got oscillations, and this mode confuses the hell out of my meters. I don't think this number is right. That number, I don't know if it's right or not, but over the tuning process I have heated the load somewhat. At any rate, it's not hard to make an oscillator out of a 555 timer that drives the TarBaby circuit just fine. Now it may still be depending on the ground loop through the instrument leads. I haven't sorted that out yet, but just doing this. But the basic principle is sound. You can do it. How long did that take me? Half an hour. Thanks for watching.